Alright, we're going to take a look at the derivation of the law of sines and the law of cosines. And so we're going to break this up into two cases. One where we have an acute triangle where all the angles are less than 90 degrees, and then we'll do another case where we're looking at the obtuse triangle. I'm not going to prove every part of the identity, but or the law of sines and cosines, but get you started and you kind of see that the idea applies, and you'll be able to finish off the proof for everything. So where the law of sines and law of cosines are used are for solving triangles that are not right triangles. So if you don't have a right triangle, you don't have a hypotenuse. So you can't do, sine is opposite over the hypotenuse or anything like that. You don't have Pythagorean Theorem, but we do have the law of sines and cosines, and that's what we're going to derive here. So we're going to start with an acute triangle, ABC, and so angles are the uppercase and the sides are the lowercase. What we're going to do is we're going to drop a perpendicular from angle B so that we can form a right triangle, and we're going to go ahead and call that height H. And now I can use the fact that sine is the opposite over the hypotenuse. So sine of angle A is going to be the opposite, which is H, over the hypotenuse, which is going to be C. The sine of angle C, so we're looking on the right hand side of this triangle that's formed into two, is going to be H over A. Okay. Now if we solve both of those for H, we'll have C times sine of A is equal to H. I'm sorry, it's not equal to H. So I went ahead and so what I'm saying here, C times sine of A, that equals H, and A times sine of C is equal to H. So that's what I'm doing there. So they're both equal to H, so they're equal to each other. And what we're going to do is divide by AC. So then we have the sine of A over A equals the sine of C over C. Now we can do the same argument, but like drop a perpendicular from angle A or whatever, and that will relate sine of C and sine of B. And so the idea is very similar, but we're going to go ahead and move on and just say that that can be done, and we have the law of sines is going to be the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Okay, so that's your law of sines, and we'll do another video where we actually apply the law of sines and solve some triangles using the law of sines. Okay, we're going to go ahead and use that same triangle to go after the law of cosines. So we're going to say the cosine of angle A is going to be the adjacent side, which we'll call B1, divided by the hypotenuse, which is C. So if we multiply both sides by C, we have C cosine of A is equal to that B1. Okay. The sine of angle A is going to be the opposite, which is H divided by the hypotenuse of C. So this C times sine of A, that's going to be equal to H. Now using Pythagorean Theorem, A squared is equal to H squared plus B2 squared. So we're using the right triangle there, the right side right triangle. And what we're going to do is we're going to go ahead and do a little substitution. So you got A squared is equal to H is C times sine of A quantity squared, plus B2 can be written as B minus B1. Okay? So B2 right here, we can write that as B minus B1. B is the entire length, and then we could chop off B1. So that's where that's coming from. And I know that B1 is the cosine of A, so we went ahead and substitute in there. So now we're going to go ahead and FOIL that out. And we have A squared equals C squared sine squared A plus B squared minus 2BC cosine of A plus C squared cosine squared A. Okay, and then we're going to use an identity which says that sine squared A plus cosine squared A equals 1. Well, I don't quite have that. I have with a c squared on it. So what's going to happen is we can factor out a c squared, and c squared sine squared A plus c squared cosine squared A. It's just going to be c squared because the sine squared and cosine squared are going to turn into 1. Okay, so that's what's going to happen here. So then we have a squared is equal to c squared plus b squared minus 2bc cosine of A. Okay, that's one of our law of cosines. Now we can play the same game and just reorientate the triangle here, and we would get the other formulas for the law of cosine. So a squared is equal to b squared plus c squared minus 2bc cosine of A. B squared is equal to a squared plus plus c squared minus 2ac cosine of B. And then c squared is equal to a squared plus b squared minus 2b cosine of C. 2ab cosine of C. Okay? So you can now basically repeat the same argument we just did here to get those other two there. Okay? So now we're going to look at another example. Well, not another example, but now we're going to derive it for the obtuse case. So we're going to start off with an obtuse triangle and angle A, angle B, angle C. And here we're going to drop our perpendicular from angle B, but it's going to be outside. Okay? Now we're going to call that H, and then that angle right there, we're going to call it H bar. I'm going to go ahead and make a note here. So the sine of A is actually going to be equal to the sine of A bar. When we're talking about like a reference triangles or whatever, so we're talking about this angle A, here's angle A bar, and the sine is positive in those two quadrants. We'll also talk about the fact that the negative cosine of A is going to be equal to cosine of A bar. So then I'm looking over here, and we got this same picture right here as we did for the sine. However, the cosine is negative in this quadrant. So we're going to be doing these substitutions. We're going to do this one in the law of sines and then this one in the law of cosines as we derive those. So just keep that in mind, that we'll make those switches as we're going through there. So let's get all this stuff out of the way and let's get going on that law of sines. Okay. Alright, so the sine of A bar is equal to H over C. So that's your height over your hypotenuse, which is C. So then C times sine of A bar is going to be equal to H. Now the sine of C, so we're treating this whole thing as our big right triangle. And the sine of C is going to be equal to H over A. So A was our hypotenuse, multiply both sides by A. A sine C equals H. And then again, I'm going to mention that sine of A bar is equal to sine of A. And we also have C sine of A bar and A sine of C are equal to H, so they're equal to each other. And then we can divide by A and C, and we get part of the law of sines. Okay. So it was actually originally sine of A bar over A equals sine of C over C, but we had mentioned earlier that sine of A bar is the same as sine of A. Okay, and then we can do a similar argument to get the sine of B involved with probably sine of B over B equals sine of C over C, and most likely would do something like drop a perpendicular here and do a very similar argument. Okay, so let's go ahead and write in our law of sines again. So we got sine of A over A equals the sine of B over B equals the sine of C over C. Okay, now we're going to use that same triangle and we're going to derive the law of cosines for obtuse triangles as well. So we're going to say that the cosine of A bar, and we're going to have to call that little orange segment there, we're going to call it x1. It's going to be x1 over the hypotenuse, which is C, and the sine of A bar is going to be equal to h over C. Alright, now B plus x1 is this whole side here, that's a leg, then h is a leg, and then that's going to be equal to the hypotenuse squared. So we're just applying the Pythagorean Theorem. Okay, so B plus x1 is going to be C times cosine A bar, quantity squared, plus h is C times sine of A bar, quantity squared, and that's going to be equal to A squared. So we're going to FOIL it out, B squared plus 2bc cosine A bar, squared, oh not squared yet, excuse me, plus C squared cosine A bar squared. So we need to put our square on there. Plus C squared sine A bar squared equals A squared. Okay. So here we got sine squared plus cosine squared equals 1, so you're just going to be left with a C squared. So we got B squared plus C squared, and then remember I mentioned a while ago that cosine A bar is going to be equal to minus cosine of A because of the fact that it's in, we can think of it as being in quadrant 2. Okay, so minus 2 cosine, minus 2bc cosine of A, and that's equal to A squared. Okay. So the rest of the derivation of law of cosines will be kind of similar to what we did on the previous slide. So that was kind of the more challenging of the batch there. Okay, so we'll make another video in a little bit here, and we'll do some examples of using the law of sines and the law of cosines.